Welcome to the workshop. Today we want to take a look at section 4.2, continuing on there. And where we left off was talking about cycles. So we want to continue on from there. Let's take a look at our notes. All right. So a path in a multi-graph, and hence a graph as well. So a path in a graph that includes exactly once all of the edges of the graph is called an Euler path. Euler path. Excellent. So Euler was a mathematician, of course, who did quite a bit of work in graph theory, hence these paths are named after him. All right, an Euler path, which of course, right, if it's an Euler path, it includes exactly once all of the edges. But when we have that and it has the same initial and terminal vertices, then it's called an Euler circuit. Euler circuit. Okay, so that it looks like that would not be pronounced as Euler, but it is. Okay, German, I believe. Not 100% certain on that. However, I am 100% certain on the pronunciation. That is Euler. All right. So Euler paths and Euler circuits contain all of the edges in a graph, but it contains them exactly once, not more than once, not fewer than once, exactly once. All right. So let's take a look at a couple of examples of Euler paths and Euler circuits. So for this graph, let's find an Euler path. All right, in this case, it's described by the edges. All the edges are labeled, none of the vertices are. So that's fine. We can give our Euler path as a sequence of edges. Excellent. So we could make this really fun or really boring. I'm going to make it a little bit more fun. I'm going to start by traveling the edge F, starting right there, and then I'm going to go along E, and then over to along D, and then C, and then A, and then B. Okay, so we can see that we can travel everything without having to repeat any edges and without missing any edges. So we have successfully found an Euler path. And what was our path? Well, we followed along F, then E, then D, then C, then A, then B. Now I say this one is a little bit more interesting because we could have actually just gone A, B, C, D, E, F. Okay, so that would have been a little bit less interesting, but certainly possible as well. So saying that there is an Euler path doesn't mean that there's exactly one Euler path. It means that there is at least one Euler path. In this case, there are a few different ones that would work. And of course, you could travel in the opposite direction as well. All right, so let's find an Euler circuit in this graph. Now this one is missing some labels, right? None of the edges and none of the vertices are labeled. So let's add some labels to this. Let's label this vertex A, vertex B, vertex C, vertex D, and vertex E. So again, we can give a path by the edges, or we can give a path by the vertices. And when we're working with a graph, that's either way is perfectly acceptable. When we have a multi-graph, we have to specify the edges. And that's what we have here. This is a multi-graph because it has these three parallel edges and a loop. Here, where we have a regular graph, we can specify the paths just by the vertices that are included. All right, so I want to travel everything here. Now, again, there's many ways that we could do this, but it's actually really convenient and really easy for us to find a path. I would say try it once to see if you can do it. Pause the video and give it a try. All right, so hopefully you paused the video and did that. But what we can do here is we can simply trace out the star and then go around the star. So we can trace out the star and then go around the star, right? And I'm able to do this without ever lifting my pen from the page. Excellent. So that tells me that I can travel the whole thing and not have to, right? Since I'm not stopping and starting a new path or anything like that. It's just one continuous path the whole way. So what was the path that I took? Well, I started at D, and then I traveled the star, so D, A, C, D, A, C. Then it was E, B, and back to D, E, B, and back to D. Now, of course, what I'm doing here is I'm definitely repeating vertices, but that's no problem. I only am concerned about edges. I have to hit all the edges, and I have to hit them exactly once, and we've done that here. So this traces out the star, excellent. And now we can just travel around and pick up these edges around the star. So E, A, B, C, back to D. E, A, B, C, and back to D. Excellent. So that is an Euler circuit for this. Now, finding an Euler circuit is not always going to be so easy. And so we actually have the Euler circuit algorithm. And this algorithm, of course, it takes quite a bit to read through. And if you don't know what's going on, sometimes it's a little difficult to see what exactly is going on. So what I'm going to do is I'm actually going to skip over the Euler circuit algorithm, and we'll move on in the next video to finding the Euler circuit in this graph. And we'll use the algorithm, but I'm just going to kind of give a general description of what's going on in each step of the algorithm. And if you like, you can return back to the Euler circuit algorithm and read for it yourself and make the connections to what we did in this example. But again, that's coming in the next video. So for now, I'll see you guys a little bit later back here in the workshop.